we'll be starting with crystal structure for our first session, and our concentration will be most probably on the basic material first, so that we can get the basic material clearly understood. Then, if possible, we'll move on towards the advanced material. Nowadays, number of advanced materials are also available, but our concentration is on the. So our first point is crystal structure. What exactly the word means, crystal structure? Some of the photographs are shown over there. So one pencil is shown over here with some sort of lead over there, and one diamond. So number of diamond pieces are shown. The material, what we was talking about, or what we should start with our first lecture, is nothing but the materials. Now two types of components are shown, or products are shown. One is the lead of the pencil, another one is the diamond. Both are carbon atoms. Both have carbon atoms. This is the most important similarity what I can suggest, or what I can say in between the both figures. But both are from carbon, this is the similarity. But if you observe related to properties, now can any, so property is nothing but hardness. So how much the lead of the pencil is hard, and if you check the carbon diamond, so very much far apart from both properties, though they seem to have similar material, but the properties are very much opposite to both. So this is very much important thing, and this we have got due to the crystal structures and its arrangement, that is the stacking of the materials. So this is the exactly thing which we will be discussing in our session. Now what exactly our presentation will deal with? Different components of materials will be dealing with that. We'll be starting with crystal structure and related terms of that, and then the structured properties and its relationship we will be dealing with. Simple cubic structure, body centered cubic structure, that is BCC and FCC patterns, space centered cubic and hexagonal closed packed structure. So different types of structures which provide the properties to the material that we will be discussing. For that you have to understand a few basic terms. This will be our first important part. Now first component or first part is nothing but the material science components. Now what you observed over here is, before dealing with the material, any of the material which performs, now the word performance is related with different things. So for manufacturing of any materials, we have to process something, we have to go on for manufacturing processes, or either you go on for getting the materials, metals from different ores. So all these steps together constitute the processing for a material. Then though only processing will not matter over here, but what type of property we will get for the material, that is also very much important. So the performance of the material may be given for a specific application. Say there are number of applications and different mechanical components which you know. So processing is very much important, and then with that only processing will not help, but we have to go on with different property. So different properties of materials, say ductility, malleability is there, brittleness, hardness, toughness, impact strength, वगैरह, all this. So the property together again constitutes, and it's based on the processing as well, so will provide the performance. But again, if you think the both component will not help, with that we require what type of exact structure, as you observed in the earlier slide, that is though graphite lead and the diamond seems from or comes from the same material, but both have different property, both have different processing and the structures, and based on that, though material is same, we get the different performance over there. So that's why after getting different researches in processing property and structure, the performance of the material is tried to be improved. So nowadays, if you check on for material science, the improvement in the materials is to be done. So the innovation word is related to all the newer materials. So engineering often means the clever use of new materials for a specific application. So a good example for change in the materials and properties, what we can say is the plastic containers which are placed of age-old metallic containers. Though, so nowadays you may observe in our, or what I can say is the kitchen equipments, kitchen tools. So nowadays plastic containers are just modified and are replacing the metal containers. Why? Because we have a number of changed properties, though some of the drawbacks are there for some of the materials, but if we get the maximum advantages for any specific material, so this is the basic of your material. Hoping that you have understood this slide, we will move towards our further slide. Now, atom stacking, that is how atoms are stacked. What type of material might be used for manufacturing this gear? It doesn't matter, the material may be same or different. You can reply in the chat box what type of components which you observed for manufacturing the gear. Now I will not go in detail of manufacturing the gear, just simple question related to our subject itself, material. Okay, good, no problem. Aluminum you are using or steel you are using iron, no problem. Again, any more material which you observed from which the gear is manufactured. We are not interested in the manufacturing material of the gear. Now how the materials are stacked, how atoms are stacked, we want to understand the same thing. And what exactly stacking means, we'll be trying that. Okay. Steel, iron, aluminum. Okay, no problem. So what this gear is made up of, this gear exactly relates the stacking of atoms. The gear cannot be directly get it manufactured from the material. Exactly that material is nothing but the stacking of the atoms. So we have different atoms over here, maybe iron and carbon atoms, maybe black atoms and white atoms. So these are the different atoms and their position. So what does the stack or stacking means? I will show you the video related to that as well. Stacking in the sense the combination of these materials. Now how these materials are hold together, why, what type of force, or what we can say, how they are constituted together. So this is exactly stacking, the position of different atoms. And it doesn't mean that we have some sort of carbon or some sort of iron atoms over here. So it is not just an ordinary or imaginary thing, but the material has some specific properties, its atom has some specific relation, and then accordingly the atoms are positioned in a specific manner. We call it as an stacking for that specific atoms. So atoms of iron and graphite, or what we can say carbon, are regularly stacked in all directions. So if you observe the direction, they both are regularly stacked. Now to just understand how the atoms will look like in the gear, I will try to show you one video. For time being, we'll just observe it and then we'll try to just elaborate and discuss on. Now the video is related to gear itself. For time being, I will stop my audio and I will try to provide you the audio related
to the naked eye. This is just a broken-toothed gear. It's made of conventional steel composed mainly of iron and a small amount of carbon. This small quantity of carbon is enough to protect the gear from corrosion, but not enough to make it indestructible over time. To increase steel's resistance, other elements are added: nickel, manganese, chrome. This way, hundreds of different types of steel are made. As we move closer, this fracture allows us to discover the structure of the alloy. A rugged landscape materializes. Here and there a scattering of white specks. They're tiny particles of dust that have settled on the surface. Each of these petal-shaped forms is a particle of steel called dendrite. An alloy of iron and carbon, dendrite is found in all solid matter that crystallizes in cooling. It's found in steel, aluminium, and even in snowflakes. When cooled rapidly, steel increases in strength, a process known as tempering. Between the particles, a cavity is outlined. We'll continue our journey through this hole, which is probably due to the aging of the metal. In the background, a grain of pearlite emerges from the shadows. It's easily recognized by its characteristic sliced structure. The thick black diagonal cutting through the pearlite contains a little more carbon than the lighter areas around it. So do the other thin lines. It's this extra carbon that gives the darker color. The fuzzy black and white flecks are faults in the structure brought into focus by the microscope. At maximum enlargement, a series of tiny regular spots appear. Here, at last, is the atomic structure of steel. Atoms of iron and carbon regularly stacked in all directions. Beyond this, nothing more is visible, for the moment.
Okay, so I think all of you have observed the video very keenly. So exactly how the atoms of iron and carbon are regularly stacked, what we can say, arrange their position, you may observe for a specific material. So the same where I have paused the video, this is exactly after the microstructure observation. So what was explained over here, or what number was moving over here in the video, was nothing but the magnification level. So for our naked eye, the gear is visible, or somewhere if we magnify it, some sort of structure for the tooth which is broken for a gear tooth is visible, but beyond that we cannot observe the things. So that things are observed with the help of different high magnified views. We call it as a magnifiers or microscopes. So to get this structure, and beyond that if we magnify, we'll get this regular stacked items for an steel of a gear. Hoping that you may have understood the basic concept of regular stacking of atoms for a gear. So this is the basic concept what I wanted to explain you for this session. So if you have doubt related to this, you can post it in the chat box. Else we can move towards our exact topic. So this is exactly to manufacture a material. We get directly the exact naked visible material And but if you go on in detailing of different materials, we'll get the perfect exact structure. So we call it as an microstructure, and beyond that, if we magnify it, we get the crystal structure. Please remember all these things for the start of this lecture, so that further things related to our subject will be easier for you to understand. Our next topic related to crystal structures is space lattice and unit cell. Now, one thing I want to mention over here, or what I want to do is, I wanted to ask one question. You have observed the video in which you observe the stacking of the items. Now, what was the important change over here in this figure and earlier video? Change it somewhat. Now, this points, you call it as a lattice point. That is, space lattice is nothing but a three-dimensional pattern of a points. These points, what we can say lattice points in this space, and every point over here in the space, what I can say, has some sort of identical surroundings for every atom. With that, what I can say is the points in the space lattice with identical surroundings are called as lattice points. So this exact rounded component, this one, 2, 3, likewise, all these rounded components will be calling as an lattice points or point lattice. And together, where these points are arranged maybe in a fashion, we will call it as suppose regular fashion, is nothing but the space lattice. Now, can anyone try to explain me, if I'm using this lattice point 1, lattice point 2, one line is shown over there. So what exactly this line indicate? Yes, can anyone try to answer? One point is over here, second point is over here, and one line is mentioned over there. For every point lattice, we have different lines. We have joined with the help of different lines. What exactly that line? So whatever lines are drawn over here are nothing but the, we can say, imaginary lines. Exactly visibility is only for lattice point and not for the space lattice. But the arrangement which you have observed in that video as well is nothing but the arrangement of this all pivot, or what we can say lattice points or point lattice. They have some functionality, they have some bonding, as you said in the chat box. They have some sort of force, we may call it as an atomic force, or maybe related to the energy, we can say, which is using them, or which is tending them to stay at their position. But so for understanding purpose, we have used this. Now, with this arrangement, we have to understand one extra word, that is unit cell. Now, if you observe this color portion, maybe blue or red, so 1, 2, 3, 4, 1, 2, 3, 4, it forms a cubic structure. One square cube we have. So this 8 atoms will form a unit cell. We call that as an unit cell. And this repeating of number of unit cell 1, 2, 3, 4, likewise, will provide us the total space lattice, and together all lattice points and space lattice with unit cell constitutes the basic phase of the material, and together all the phases constitutes the material and its visibility. So hope same thing related to unit cell. So this exactly some sort of GPU we have unit cell, all the atoms are there, dotted line indicates, or this line indicates the outer and inner structure, inner atoms, you can say, and repeating of all this unit cell together constitutes a this. So this unit cell together, number of unit cell together forms a crystal, which is nothing but a brick by brick observation. So one unit cell constitutes with other unit cells. So if you observe the manufacturing of a wall, how this wall is created, so one brick you may call it as an unit cell, and all this together unit cell will form a crystal.